inside 30 seconds. The Eagles have no timeouts. Wait a minute. Here's a free foot. I don't believe it. The Eagles pick it up, and Herman Edwards runs it in for a touchdown.
Motion man is Andrew Hawkins, who's back in there after missing a couple of games. That ball bounces around, and it's intercepted.
Yeah, that's a fumble right there, not an interception.
Montana quickly to Jerry Rice, and he's got some speed. He drops the ball. Rice chases it, doesn't come up with it, goes into the end zone. The scramble continues, and the Giants come up.
Pocket collapses again on Stafford, and he is going to pitch it. And the ball is on the ground. Minnesota scoops it up, and on his way into the end zone is Daniil Hunter. That is a touchdown.
Aguilar loses it. Scramble on the fumble.
Hello and welcome to today's webinar. My name is David Cash, and I'm glad that you've taken the time to join us today, and I hope you find some information that will provide you today as we look at our topic useful. And that topic is stop screw fumbles with the use of an automated screw feeding process. So let's go ahead and jump right in. Obviously, we want to help to avoid any type of fumbles as it relates to fasteners, and those, as we depicted there in the opening, that those fasteners are being used, picked up and placed onto the tool, and those fasteners in some cases can fall onto the ground, on the workbench, and create an issue for safety within the facility. And so that's what we're going to try to look at, a way that you can help to avoid that in your process. And so when we look at the use of a tool, a power tool, whether it's an air tool, an electric tool, a DC or a clutch tool, oftentimes manufacturers will move to these types of tools from a manual process, possibly. But there can be a slowdown in the actual process of doing the fastening with a hand tool. And so we want to try to increase our production with the use of a power tool or an air tool in this case as well. And you want to be able to improve the process control as we move through the assembly process, and being able to get the fastener into the part easily is one of those things that can be challenging when working with an air tool or a power tool. They can be a little bit cumbersome at times, for sure. And so if there's a way that we can help to automate that process slightly, then we can help to increase the production and increase the throughput. That may be something that you're looking for within your application. Now, again, if we're transitioning from a manual tool to this, the operators themselves may, if they're not used a power tool before, it may be a little bit of a learning curve on how to deal with those items. And some of the production aids that can help with that transition are going to be things like we're seeing here, a torque arm. And what this arm does, it does a couple things. First, this style of arm is an articulated arm, meaning that it acts very much like a human arm with an elbow, giving us a full range of motion to be able to use this tool, but it does help keep the tool perpendicular to the work surface. So there is a spot at which the tool remains. So it makes it a little easier for the operator to put the fastener either on the bit of the tool, or it could be into the part itself, and then positioning the tool to the workpiece. Now, these arms are available in a number of different styles and configuration depending on the application itself. But there are linear type torque arms, which basically means that the tool can move in and out and then around an access point. But again, keeping the tool perpendicular to the work surface. We also have telescoping arms, and those basically allow the tool to have full range of motion, but we are keeping the tool secure. Because one of the things that the torque arm does very well is help to protect the operator from any type of carpal tunnel or repetitive motion type of injury when the tool shuts off. And so anything typically above 15 inch-pounds or so, it may be a good idea to put that tool in an arm to help protect the operator. It also gives a 100% transfer from the tool to your part, so we're not losing any reaction that happens in the tool when it shuts off. And so the telescoping arm, again, allows you to be able to be very, very nimble with the tool itself. And then one of the other production aids that go hand in hand with either a telescoping arm, or if you're just going to use the tool by itself without an arm, is going to be the use of a balancer, a tool balancer. And there are a couple different types of these balancers. We have a spring tension type of balancer, which as the tool gets pulled down to be used, there is some tension on the tool itself. So if the operator lets go, the tool will retract back up into the as much tension that the arm has. And these are typically an entry-level type of balancer. And then there's another step up, which would be the zero gravity balancer. This basically allows you to position a tool in any spot, and the tool will remain in that location. So as the tool is being used, there is no weight on the operator, and the operator can go ahead and use the tool without any tension that's being created from a tension type of balancer, and then position the tool and leave it there, and the tool will remain. So that's the kind of the difference between the two styles of balancers that can be used in conjunction with a power tool. And then there is another type of screw feeding type of application that can be used, and that would be the use of a screw feeder, or sometimes called a blow feed system. And what this is we fill up the bin there with the fasteners. Those fasteners get into the bowl, which has a vibration function to it, and it causes the fasteners to kind of creep up to an area where they are then shot or blow fed right to the end of the tool, and then the tool is used. So every time the tool is used, a new fastener gets shot to the end of the tool, and the operator can go ahead and use it. Now, these systems do have they can be a little bit expensive, and they can be a bit finicky. And when one of these systems goes down, it can be a little bit time consuming to try to get that worked out. But nevertheless, the screw feeder is a popular type of production aid as well. But we're presenting a little bit of a different solution, and that would be the use of a screw presenter. And the screw presenter again gives us a much lower cost to entry to help being able to present the fastener with the whatever fastener we are using to the operator. And those can be done a couple different ways. And so there are basically two types of presenters. We have one that has a rail system or more of a guide, very similar to a pole vault type of scenario, where we have our driver and our bit, and that bit goes down through that guide and grabs that fastener, and that's done magnetically. And so we either magnetize the bit, or we can use some magnets that go around the bit to help with that process, and we'll show you what that looks like here in just a minute. But there also is another style of presenter, which is our automation style of presenter for those that may be using stainless steel fasteners or a non-magnetic type of fastener. And how this works is there is a turntable that typically has 4 spot locations. There are 2 spots that have fasteners in it, one spot that is waiting to be picked up, and then another spot that is empty. And so the driver will come over, and it will suck up that fastener through the use of a vacuum pickup, and we'll show you what that looks like. And then after that, the turntable will rotate, and a new fastener will be ready to present. The empty spot will be filled, and then there'll be one waiting and one emptied. And so that's how we can help to automate the process with the use of a screw presenter that is again a small footprint and very, very easy to use. And so if we look at the automation type of presenter, we have a driver that's on the end of a cobot here, and that will go ahead and it will come over to the presenter, goes down to the pickup area, and then it sucks the fastener right up with the use of a vacuum pickup. And then it goes and dispenses the fastener and returns back to grab the next fastener that it needs for the operation. So that's how the automation driver works in conjunction with a robot or that. But again, the automation one can be used as well with a manual or a power tool in this case. And this gives us a good look at what the actual vacuum pickup looks like. So there is an assembly that goes on the nose of the tool. That assembly has a collar that goes around the length of the bit, and then you see the tube there at the end, which is our vacuum source. And then as the tool gets over the fastener, the vacuum just sucks that fastener right up to the tip of the tool, and then we can go ahead and use that tool to go ahead and fasten the part. And so again, this is the automation presenter being used in either conjunction with a electric tool or a robotic type of system that can be used either way. So with the rail or the guide presenter, this gives us a look of how that functions. We just position the tool over the top of the area, go down, we grab that fastener, and then a new one is presented to us. So how does all of this kind of work? Well, first it does allow us to again have a compact dispensing area. It does help to eliminate the use of shaker trays. It does help to automate the fastening process, and again, it helps to stop fumbles, which is part of the things that we are trying to accomplish with that. The guide that is used on our website. So if you've got a different style of fastener, you want to make sure that it's going to work in your particular scenario. We have a worksheet that is available again on our website that allows you to measure your fastener and help select the correct presenter for you. And so some of the dimensions that you're going to need is going to be the head diameter. You're also going to need the head height. You're going to need the screw length portion of the fastener, and then the shaft diameter as well. And there is one caveat to being able to use a presenter. The screw itself needs to be longer than it is wider, and that is because of how the fastener gets presented at the end of the presenter for that. So how does it all work? Basically, we have a hopper, and then there is a rail system that, as the fasteners get brought up to the top of the hopper, it will fall down, and then the sweeper arm will orientate the fasteners into the rail system. That rail vibrates, causing the fasteners to move towards the end of the rail. And so that will trigger a sensor that is at the end of the rail to stop the process once there is a fastener at the end of the rail. Now, the rail system itself can be adjusted to accommodate different size fasteners. So you can use the same model to allow you to adjust for different fasteners, but you can really only use one at a time within the use of the presenter itself. But you can see there that rail, which would be towards the left portion there. We have little plates that you can sandwich in between the rails that allow you to make that adjustable either wider or more narrow, depending on the shaft diameter of the fastener that you're using. And with this is how it gets picked up when you go through the guide. You just simply pull down and grab the grab the fastener with the bit. And because it's magnetic, it just simply stays at the end of the tool here. So let's go ahead and we can look at the demo portion of this, which gives you kind of the same similar look that what we just saw. But so I have the presenter here. If we go ahead and turn that on, that will activate the vibration and the sweeper arm. Once the fastener is at the end of the rail, it shuts off. We can go ahead and take the tool, and again, this is a magnetic pickup. We can go ahead and run our fastener. The next screw gets presented, and we can grab that one and run that down. And so it makes it very easy for the operator. They don't have to pick up the fastener. They don't have to worry about trying to put it on the end of the tool or starting it in the application. All of that kind of helps with the actual output of the driver. And in some cases, we can see an input or a throughput increase of up to about 50% for that actual use of the presenter. And so there are several adjustments that we can make to the presenter itself. We can adjust the height of the rail guide. We can change the amount of speed that happens through the vibration. And so if you have any questions about if a fastener is going to work for you in your application, you can send a group of fasteners, 50 or so, and we can go ahead and pre-fit those for you and make sure that it's going to work in your application. If you have any concerns about it doing that, because there are some adjustments that need to be dialed in for this to work, but we can certainly help to accommodate you if you have those concerns, if it's going to work for you. You can send us the fasteners and we'll go ahead and make sure that it will work for you. So again, this presentation is pretty quick, but sometimes it's very difficult to understand if you don't see it with the use of the presenter system. And so with that'll go ahead and lead us into our questions and answers for today's presentation. Again, a nice quick presentation right before the holidays. So Chris, do we have any questions?
Hello, Dave. One question we have is, can these be used with an air screwdriver as well?
Yeah, so this certainly can be used with a pneumatic style of tool, with a magnetic type of bit, as well as a vacuum pickup that can be used as well. So an air tool can be used. So it could be an air clutch tool, it could be a pulse tool, a number of different ways that we can use that. So again, it just depends on the size of the fastener. I mean, we can go with our automation one down to an M1, up to an M8, I believe, is that. But yeah, those are available to be used with an air tool as well.
All right. Another question we had is, are these compatible with like stainless steel type of fasteners?
Yep, any fastener that again is longer than it is wider. If it can't be picked up through the use of a magnet, we would use the vacuum pickup style to be able to go ahead and use that. Now there's some cost to modifying the end of the tool with a custom mouthpiece, and that mouthpiece again, would be specific for that particular fastener. So to be able to pick that fastener up and use it, that mouthpiece would be designed for that particular fastener. So stainless steels would be used with the vacuum pickup, and that vacuum pickup would be designed for that particular fastener.
All right, I think that's all the questions we had, Dave.
All right. Thank you very much for joining us today. I hope you found some useful information, again, that you can use in your area to help stop any fumbles that may be happening or occurring. And hope everyone has a nice holiday season, and we will look forward to seeing you again next year. Thank you so much, and have a great day.